Triangle similarity is a little bit different than proving that polygons are similar in the fact that you only need 3 bits of information. You don't need to have all the sides proportional and all the angles congruent. So, triangles are similar by SSS if the 3 sides of a triangle are proportional to the corresponding 3 sides of another triangle. So what we're going to do, the easiest way to do this is to list the sides in order, either from smallest to biggest, biggest to smallest, but don't try to compare two. Just write 9, 12, 15. Then I'm going to do these in order. 9, 16, 25. And finally, we're going to put this in order. 1.5, 2, 2.5. Now what you want to do is you want to simplify it as much as is possible. You want the 3 numbers to be relatively prime to each other, so there's nothing else that can be factored out, and you want it to contain no fractions or decimals. So in this set, I can divide a 3 out from all 3 of those, so I'm going to change it so that it's 3 to 4 to 5. That's the ratio of the sides. In this one, even though they're all perfect squares, you can't, there's nothing that they have in common besides a 1. So we can't factor that out. So this ratio is 9, 16, 25. And finally in this, I have 1.5 and 2.5. So I'm going to double all of these numbers so that I do not have decimals anymore. So 1.5 times 2 is 3. If I double that, I get 4. And if I double 2.5, I get 5. And take a look. Your first triangle, triangle A, is similar to the last triangle. And that's how you can tell triangle A is similar to triangle C, because their sides are all proportional to each other. So that's SSS, and the easiest way is, again, to line them all up. The sneaky one is SAS similarity. And that's going to be the same thing almost as the congruence as far as how we write it. If 2 sides and the shared or included angle, remember that's how they like to say it in our book, if 2 sides and the shared or included angle of a triangle are proportional to the corresponding 2 sides and shared angle of another triangle, then the triangles are similar. Now remember, the angles will be congruent. The sides will be proportional. So what I want you guys to do is I want you to hit pause and I want you to try and figure out, are the triangles similar by SAS? Which means the sides are proportional and the angle that's in between is the same. So take a moment and see what you think, and I'll reveal the answers to you. Okay, now for the answers. Here we have a 68-degree angle and another 68-degree angle. So we're going to check out the sides on either side of it. And we've got 8 and 12 and 6 and 9. Let's see if they're proportional. Is 8 over 12 equal to 6 over 9? If you reduce them, they would both become 2/3. Or you could cross multiply and find out if they're equal, such as you could put 8 over 6 and then put 12 over 9. Are these the same? Well, 72 does equal 72. So yes, the sides are proportional and the angles are congruent. These triangles are similar by SAS similarity. And since they're similar, all of the sides are proportional. So I would be able to fill in that this angle here is 60 degrees. I would be able to fill in this angle by setting up this side by setting up a proportion, you could fill in a lot of information. This second one, yes, we do have an angle in common, a 50 and a 50. It is not in between the same two sides. We have no idea what is happening down here with MO. If this had been a 3, we could say it was SAS, but we can't. Here we have a set of proportional sides. 14 to 16 is indeed equal to 7 to 8. But again, the angle that's shared between them, we have no information on. We could find angle K just by adding these J and L up and subtracting it from 180, but we can't definitively say what angle N equals. So there is not enough information. So we're going to check out the last situation, which is the easiest, and it's the way that we're going to do all of our proofs. It's AA similarity. If any two angles of a triangle are congruent to the corresponding angles in another triangle, then the triangles are similar. If two angles are congruent, the third angle will automatically be congruent. So I'm going to have you guys check out the scene, not in this first one. We're going to save this for class. But I am going to see if you can get the answer correct and bring it. I like to pretend that each of these angles is something. I put in, for example, if this is 20, then this would be 70. If this is 20, then this piece here is 70. And if this one is 70, then this down here is 20. And what I do is now set them up. If I said in the big gigantic triangle, triangle TUV, that means I was looking at the 20-degree angle, then the 90-degree angle, and finally the 70-degree angle. Could you write a similarity statement using this triangle here and what I'm going to call triangle 2 over there? Try it out and bring it to class. But we're going to move on to this other one. In order to prove that triangles are similar, you do need two sets of congruent angles. I've got one, 43, and I'm hoping that you can see the other set of congruent angles right now. If you chose the vertical angles, you're correct. So now we can set up some proportions. 2a plus 2 is going to go with a plus 5, and 9 is going to go with 12. You set up any proportion you want. I'm going to do 9 over 12. So if I choose to do that, think about who would need to go in the numerator over here. A plus 5. And 2a plus 2 is on the bottom. Now I can do a little canceling, and I'm going to. I'm going to say that 3 goes into that 3 times, 3 goes into that 4 times. Do not get suckered into canceling these a's out. There's addition involved. It means your life is over. You can't cancel anything out. Let's cross multiply. 4a plus 20 is equal to 6a plus 6. If we solve this, we're going to get 2a. I'm going to subtract 6, get 14, and conveniently, a works out to be 7. We're going to save the proofs for class, but all of these are going to be done by using AA similarity. So your whole goal is to try and get two sets of angles to be congruent.